This is RD Sharma solution, class 12, chapter 1 relation, multiple choice question MCQ we are looking at. The first question is, let R be a relation on set N given by, so this R is given by, relation is always a condition, so this is A comma B, and where this A is equal to B minus 2 and B has to be greater than 6. Greater than 6. And the important part is this is on natural number. Natural number are counting numbers. So there are 4 options. So I'll just take one of them and let us see whether the condition is followed or not. So if I put 3 and 8, because A will take as 3, B will take as 8. So A, 3 equals 8 minus 2. This is going to be 3. 3 is not equal to 6. So 3, 8 is not true. Take one more option, 6, 8. A we are going to put as 6 and B we are going to put as 8. So 6 equals 8 minus 2. 6 is equal to 6. So that means the C is correct one. If a relation R is defined on the set Z, Z is integers as follows. So this is given as A square plus B square equals 25. So the domain of R is. Now I just want to take you to VSAQ, very short answer question. And the first question of VSAQ is exactly similar to this one. So we have already discussed that in stretch and you know how to do that, or otherwise you will refer to it. Question number 3. R is a relation on the set Z of relation. The integers and it is given by x, y belong to R, and this is implying x minus y is less than equal to 1. R is a 4 options are given, so we'll just take one by one. We'll take one by one. Reflexive, I'm taking, what do you have to do? Put y as x. So x minus x, and mod is what? This is 0. 0 is less than equal to 1. So this is true. This is reflexive. So first, there are different options. So first is true. Means reflexive, we have made it as true. So we'll check for all these 3. Then we'll see which options we have to choose. The second one is symmetric. Symmetric means what? This is reflexive. This is symmetric. Symmetric is, I'm just changing x as y, y as x. So x minus y, y minus x. Since this is a modulus, that is, we have a mod sign here. That means y minus x can be written as negative of x minus y. So mod of negative value will be positive. You can always write it as minus 1 into x minus 1. Minus 1 you can take out. Minus 1 mod is plus 1. So these two are exactly similar. That is, if this xy holds, yx also hold. So that is how this 2. So we can see that it is reflexive also, symmetric also, but we'll not get to the conclusion because we have to check for transitivity also. So transitivity, this is x, y, z with 3 we are taking, x and y. So at mod of x minus y less than equal to 1, mod of y minus z is less than equal to 1. So x minus y, there is no possibility from here whether we can find out x minus z is less than equal to 1 or not. X, because x minus 1 is x minus y is less than equal to 1, y minus z is less than equal to 1. It is not always true that x minus z will be less than equal to 1. X minus z will, we don't know that. I'll just give you a kind of guess. How do I find out? Take it as 1. X minus y equal to 1, y minus z equals 1. I'm taking it as equal. So just add these two. We get x plus x minus z equals 2. Now just add this less than equal to. I'm just taking a kind of way we can understand this. x minus z is less than equal to 2. It is not less than equal to 1 still. So we know that this is not transitive on z. Since there is a gap from 1 to 2, because previously x minus y less than equal to 1, y minus z is less than equal to 1, but what we are getting here is x minus z is less than equal to 2. So there is a slight gap, and this gap made us understand that this will not always be transitive. This may be transitive, I don't know, but it will not be always transitive. So B is the correct answer. Question number 4 here. The relation R defined on the set A. I'll write the relation. First, let me just write it here. A comma B. This is modulus A square minus B square is less than 16. This is given by. So the answer is none of these. What we'll do here is, the set A is what we'll take from. The set is given already. It's 1, 2, 3, 4, 5. Set B will always A only, because we are dealing with A cross A. So same thing. My handwriting is not good, so kindly deal with it. What can I do? Anyways, A is this, and the B is also A. I'm just writing it as B just to show you that we are taking A cross B. Here A and B are same. I'm squaring it now. 1, 4, 9, 16, 15. I'm squaring it, because we'll not be dealing with actual set. We will be dealing with A square minus B square. But when we'll be writing the answer, we will be writing the set values, not the squared value. This is square value just for this expression or the condition which is being provided in this question. So now I'm going to take one by one. 1 minus 1, I'm taking A square and B square. 1 minus 1, 1 minus 4, 1 minus 9, 1 minus 16, and 1 minus 25. Similarly, 4 is taken, and this will be this all on the B dash will be subtracted from here. 4 minus 1, 4 minus 4, 4 minus 9, 4 minus 16, 4 minus 25, like this. Similarly, 9 also, 9 minus 1, 9 minus 4, 9 minus 9, 9 minus 16, 9 minus 25. So all this you have to do. Now why I am writing all these, you will just see. Just see, because this kind of question will be, these are given in MCQ, but this will take some effort. So 16 all I have written, and then 25 minus 1 till 25 minus 25. Now you see here that all these, I'll take the first row here. Other I would like you to do. Mod is there. Please remember that this is modulus. Modulus has to be less than 16. 1 minus 1, 0, less than 16. 1 minus 4, minus 3, minus 3. So minus 3, it is not 4, minus 3 it is. I have just miswritten. 1 minus 9, minus 8, so it will be positive 8. 1 minus 16, minus 15, positive 15. 1 minus 25, the positive 24. Okay, so which all is less than 16? 0, 3, 8, 15, 24 is not there. So I will just take 1 and 2 from here. 1 and 5 from here, sorry. 1 and 5. Not 1 and 2. 1 and 5 from here. Because 1 and 5, the subtraction was 24. Here, 25 minus 1, 25 minus 4, like this. So 24, please remember it is all modulus. So there are two mistakes here. 4 I have written, it is 3, and this 1 minus 24 we have to take as 1, 5. So 1 comma 2 which I have written has to be taken as 1, 5. Now see here, 24, 21, 16, which all is less than 16? Only 0 and 9. 24 is not, because 24 is not less than 16. 21 is not less than 16. 16 is not less than 16. So it's not less than 16. So we just cancel it out. 9 less than 0. So how do we take this? 5 and 4. 25 minus 16. 5 and 4 we are going to take. Here we are going to take 5 and 5. So this is 5, 4, and this is 5, 5. So I hope you got an idea. Means 1 and 5, first one was there. Then the last one which I took as 5, 4, 5, 5, you have to add in between. And since when you add all these, you will see that this is not the option in this question. So none of these is the answer. Question number 5. Let R be the relation over the set of all straight lines in a plane such that L1 related to L2. How they are related? L1 is perpendicular to L2. One line is perpendicular to the other one. Perpendicular means both lines are intersecting at an angle of 90 degrees. Then we will say they are perpendicular. So one line. Can a line be perpendicular to itself? No. A line can be parallel to itself. It cannot be perpendicular to itself. So this is not reflexive. Second one, symmetric. So one line is perpendicular to another one. This is L1, L2. So that second one will also be perpendicular to the first one. This is symmetric. True. Transitive. One line is perpendicular to another one. The third line is perpendicular to the second one. Are they parallel? No. Are they perpendicular? No, they can be parallel. So this is not transitive. So it is only symmetric. Question number 6. If A, B, C, then relation R equals B, C on A is. So there will be a concept which is coming. We already discussed it while in the previous exercises. Relation, only one thing is given. Only one ordered pair B, C. B, C, since if we want this to be reflexive, A, B, B, C, C has to be there. So it is not reflexive. It's not reflexive. Symmetric, if BC is there, CB should also be there. It is not, so it is not symmetric. Transitive, we need third element. Since we just have B, C, we don't have, say, if for example BC, CA was there, we can say BA is not there or BA should be there. Since we are only given B, C, how can we decide whether it is transitive or not? So by default, we assume it to be transitive. This is the concept you need to learn. We assume it to be transitive. Question number 7. Let A equals 2, 3, 4, 5, 17, 18. A is 2, 3, 4 and this goes up to 17, 18. Now, there is an equivalence relation. The symbol of this equivalence relation is like this. A line over this we have a tilde. Okay, this is this symbol will be the equivalence relation of A cross A, Cartesian product of A with itself, and this is defined by AB is equivalent to CD if AD equals BC. If AD equals BC, so only when AD equals BC, these two will be equivalent. Let me just write the condition of equivalency. AD, that is the multiplication of the extremes, equals the multiplication of the internals. Let us see the answer here. How to get this? The trick here is just multiply, because if you actually do the way I told you, you have to write from 2 to 18, then other 2 to 18, find all the combination. That is very time taking, cumbersome. Best way is to take these 3, 2 and just multiply with the natural number. 3 into 1, 2 into 1, 3, 2. This is 3, 2. 3 into 2, 2 into 2. So what do you get? 6, 4. 3 into 3, 2 into 3. So what do you get? 9, 6. 3 into 4, 2 into 4. What do you get? 12 and 8. 3 into 5, 2 into 5. What do you get? 15 and 10. 3 into 6, 2 into 6. What do you get? 18 and 12. 3 into 7, 2 into 7. What do you get? 7 is 21 and 14. So 21 and 14. Because 21 is not in the set, so we outrightly deny it. So we will take from 3, 2, 6, 4, 9, 6, 12, 8, 15, 10 and 18, 12. So why did I do this? Because AD equals BC. Let me take an example. You take any of this, 3, 2. If it is equivalent to 6, 4, then 3 into 4 equals 2 into 6. So 3 4s are 12, 2 6 are 12. So you can write 12 as 2 into 6. and 2 into 6 is already there. You can cancel 2. You can cancel 2. So 6, this 6 equals 6. You can also cancel 3 also. 6 ones are 6. You can cancel both of them. So they are equivalent because 1 is equal to 1. They both boils down to the same thing. Question number 8. Let A equals 1, 2, 3. The number of relation containing 1, 2, 1, 3 which are reflexive and symmetric but not transitive. Okay. So A set is given as 1, 2, 3. And this is also given that 1, 2 and 1, 3 is already there. So number of relation containing this which are reflexive and symmetric and not transitive. First it has to be reflexive. So 1, 2, 3 is there. So you have to add 1, 1, 2, 2, 3, 3 in order for them to be, or for this relation to be reflexive. 1, 1, 2, 2, 3, 3 you have to add. We added this. Coming to symmetric. Symmetric is what? 1, 2 is there. 1, 2 is there. So you have to add 2, 2, 1. 1, 3 is there. You have to add 3, 1. What I am trying to suggest here is, in order to make it symmetric, 1, 2 is there. That is AB is there. BA should be there. 1, 3 is there. 3, 1 should be there. Right? Now, since all this we have taken, and this is reflexive and symmetric, but you will see, I guess we have discussed in the previous questions also, it is not transitive. You can try any of these. It is not transitive. It is not transitive at all. Question number 9. So the relation is like this. R equals xy. Xy belongs to z. This is belonging to the integers. And x square plus y square is less than or equal to 4. Please remember, x square plus y square is not equal to 4. It is less than or equal to 4. Here, the things will change. If it would have been x square plus y square equals 4, things were different. The answer would be different. We have to find out the domain of R. So x will tell you the domain. Y will tell you the range. This is the question. What do you do now? X square, because you have to find out the value of x, you can write x square as 4 minus y square, because x square plus y square is less than or equal to 4. Always think that x square plus y square equals 4, but remember that it is less than, and second thing you have to remember is x and y has to belong to the z. Z means integers. So x square can be written as 4 minus y square. So we have to see what all values of x are possible, and what all values of x are possible is the domain. Right? So what we'll do? This is less than or equal to, don't make it as equal, otherwise things will change. X square equals 4 minus y square. Now I am taking y equals, see, y is 0, I am putting y as 0. So x square is less than or equal to 4 minus y square, 4 minus 0, that is 4, 2 square, or you can say that even if you equate, you shouldn't equate. First thing is clear. I'm just saying that even if you equate, it will be plus minus 2. You have to see whether it is less than or equal to, or if you want to find out, you can equate it. So x square less than or equal to 4 minus, now I am putting y as plus minus 1. So you get 3. So you won't equate it. Why don't you equate it? X square 1, because of this 1 plus minus 1. So it is defined. X square is defined, but x equals root say 3. Just take it as 3. So it will be something 1.732. But still less than or equal to sign is there. Less than or equal to sign is there what? Because we need an integer. 1.732 is not an integer. So you have to take 1, because x is only possibility is 1. Less than or equal to, just less than or equal to. 1.732 is not an integer. You have to take 1. Now coming to putting y as plus minus 2. Y as plus minus 2. So put it here. This is 4. So x square less than or equal to 0. What do you get? X equals, it will be 0 only. It will be 0 only. Okay, till here it is okay. Now, let us put y equals plus minus 3. And here it will fail. Y equals plus minus 3. X square is less than or equal to 4 minus 3 square. It's 4 minus 9. It's minus 5. So this is not possible, because whatever you take x square, whatever value you put in x, it is an integer. It will always be on the positive side of the number line. It will always be on the positive side, right? So what do you see here is this here, the condition breaks. It's not possible. So when you get plus minus 2, plus minus 1 and 0, this is the domain. So 0 plus minus 1 I am taking here. So minus 1 on the left hand side, plus 1 on the right hand side. Then plus minus 2. So plus 2 here, minus 2 here. So let me just make a round here just to indicate that this is the domain which we found out. This is the domain which we got. This is your answer, right? Question number 10. A equals 1, 2, 3, B equals 1, 4, 6, 9. R is a relation from A to B defined by X is greater than Y. The range of R is. So X has to be greater than Y. The range is all the values in the ordered pair. First value will be domain. The second value will be range. Let us write the set here. Set is 1, 2, 3. 1, 2, 3. B set, because it is given that it is B set, 1, 4, 6, 9. 1, 4, 6, 9. So what range will come? First, let us see with the ordered pairs. 1 is not less than 1. 1 is greater than, not greater than 1. 1 is not greater than 4. 1 is not greater than any of these. Any of these. 2 is greater than 1. So 2 1 you will write. 2 is not greater than any of these. Now, leave. 3 is greater than 1. Yes, just write 3, 1. And 3 is not greater than 4, 6, 9. So only this is the relation. This is the relation. So 2, 3 will be domain. The first member I am taking. And 1, 1, 1, 1. That is only 1 will be the range. So range will be 1 only. Question number 11. A relation R is defined from 2, 3, 4, 5 to 3, 6, 7, 10. And it is related to X, R, Y. That is, X is relatively prime to Y. Now this again, the question we have already done, relatively prime. This question already done in our 9th question of VSAQ. You can just follow there. You can go there and you can just have a look. But I'll just tell you, two numbers are co-prime when the greatest common divisor is 1. That is, they cannot divide both the numbers, or there is no number which can divide both of them. Only one can divide. So let me write it here. The first one is 2, 3, 4, 5. The second one, which is B, or you can say set B, is 3, 6, 7, 10. Now X and Y has to be relatively prime. So you have to choose only those values. I'll just take one of these, say 2, 3. Now 2, 3, there is no other number which can divide both of them except 1. So 2, 3 you can take, 2, 6 no, 2 can divide, 2, 7 you can take, 3, 3 no, 3, 6 no, 3, 7 you can take, 3, 10 also you can take, 4, 3 you can take, 4, 6 is not possible because 2 can divide them, 4, 6, 4, 7 you can take, 4, 10 no, 2 can divide it. Now 5, 3 you can take, 5, 6 you can take, 5, 7 you can take, 5, 10 they will be divided by 5. So this is the final answer. The domain will be what? All the first values take. 2, domain will be all the x values or a values of a comma b, or x values of x comma y. So 2, 3, 4, 5. This is the domain. This is the only domain. First values you can take. Question number 12. A relation 5 from C to R is defined by x, 5y implies mod of x equals y. Which one is correct? Now this C is complex number. C set is a complex number. R is real number. And this is defined as x, 5y implies mod of x equals y. Now, since x is a complex number, we are not talking about negative values becoming positive. This is not positive, negative making. This is a proper conjugate, or sorry, the value which is coming out of a complex theory, and that is going to be the modulus. I'll tell you how to find out the modulus. The modulus of this 2 plus 3i is 2 square plus 3 square under root. And it has to be equal to 13. Is it equal? 2 2s are 4 and 3 3s are 9. So you get under root 13, which is not equal to 13. So it fails. Second one is given as 3 5 minus 3. Now 3, how to write this? 3 plus 0i, you can write like this. What is the value? Under root 3 square plus e 0 square, that is the modulus. So this also fails because 3 is not equal to minus 3. Third one, 1 plus I. So you take, this is 5 2. So 1, this is 1 square plus 1 square. So you get under root 2. Under root 2 is not equal to 2. So this also fails. Fourth one we take. Fourth one is, this is only I. I can be written as 0 plus I. So you take 1 from 0 from here, 1 from here. 0 square plus 1 square. This is going to be under root 1, and under root 1 is 1. So 1 is equal to 1. So this this is true. The fourth is the correct answer. D is the correct answer. Okay guys, this question we will take in the next discussion. Till then, thank you so much. Take care of yourself.